The Audi A3 e-tron is a plug-in hybrid vehicle with an electric drive that protects the environment and allows the vehicle to be driven extremely efficiently. The e-tron has a total range of up to 940 kilometers, of which 50 kilometers can be purely electrically powered.
The Audi A3 Sportback e-tron is very powerful. We're now going to show you which components and mechanical units are necessary to convert the electrical energy into torque on the road, as well as which parts relate to safety.
The environmentally friendly power of the e-tron comes from the high-voltage battery. This lithium-ion battery is installed in the rear end floor, in front of the rear axle. A sticker on the housing warns about the risks of handling the battery. The sticker is affixed to all high-voltage components and includes the following information. It warns about the electrical current, against touching current-conducting parts, and indicates that the operating instructions must be observed. 8 cell modules and their associated controllers are located inside the battery housing. Each cell module consists of 12 battery cells. The cell management controller measures the voltage in the individual battery cells and the temperature of the cell module. The SX6 switchbox battery junction box is located on top of the cell modules. A high-voltage fuse can be found inside the switchbox. The power contactors and a current sensor are installed under the printed circuit. The J840 Battery Management Controller, or BMC for short, is located on the rear side. The BMC monitors the safety equipment and causes the power contactors to open and close. The BMC deactivates the high-voltage system in the event of a collision, or if a safety line opens. You can find the connector for the high-voltage battery on the front edge. The cell blocks are kept at an appropriate temperature with the help of heat sinks, which connect to every 2 cell modules. The subshell of the housing is made from robust cast aluminium and features heat insulation. The orange-coloured high-voltage cables are routed along the underbody. The cables connect the high-voltage battery and the power and control electronics in the engine compartment. The power and control electronics convert the direct current from the high-voltage battery into 3-phase alternating current. This conversion is performed via pulse width modulation. Changing the frequency controls the speed, and changing the shifting times controls the power. A direct current converter that provides the 12-volt onboard supply is included with the power and control electronics. The power and control electronics are cooled via low-temperature coolant circuit 2. The coolant expansion tank for the high-voltage battery, the power and control electronics, and the high-voltage battery charger is located directly next to the coolant circuit. Thanks to the heat exchanger for the high-voltage battery, the coolant can be cooled on demand with the refrigerant from the air conditioning system. The electric air conditioning compressor replaces the belt-driven air conditioning compressor and is also a high-voltage component. The electric air conditioning compressor is supplied with 352 volts by the high-voltage battery charger via a high-voltage cable. The high-voltage heater also belongs to the high-voltage system. During electrical vehicle operation, this mechanical unit heats the coolant for the heat exchanger of the heater in the interior. This heater and fresh air ventilation system is bolted to the underbody from below. The maintenance connector is located on the top edge of the engine compartment. This connector is an essential safety component that can be used to de-energize the high-voltage system. Push the red catch downwards and pull it out. With the catch pressed down, pull out the interior part of the connector. To prevent the high voltage system from being switched on again, the maintenance connector is secured with a lock. Remove the lock to switch the high voltage system on again. Open the catch using a suitable tool. Then press the red catch downwards and push in the interior part of the connector. Finally, push in the red catch again. The etron is driven by a combustion engine and an electric motor. A dual-mass flywheel on the drive shaft of the engine absorbs vibrations. The electric motor is also located on the drive shaft. The electric motor works as an alternator and generates current when coasting and braking. After the electric drive motor, there is a 6-speed dual-clutch gearbox with the designation 0DD. The mechatronic unit is located under the black housing cover. The high voltage connections and the connections for low temperature coolant circuit 1 are located on the housing itself. The high voltage battery charger is installed at the front of the engine compartment. The charger has a maximum charging capacity of 3.6 kilowatts. The battery charger contains a pulse inverter that converts the alternating current from the Audi e-tron charging system into direct current. The direct current is then used to charge the high voltage battery. You can choose between two charging modes on the charging connection under the front grille. Press the bottom button to start the charging process immediately. Activate the charging timer by pressing the top button. The red LED indicates which charging button is active. An industrial or domestic socket can be used for the charging process. The 12-volt battery is charged in the normal way. The connections for the charging cables can be found in the fuse box for the battery positive terminal and on the body for the battery negative terminal. Repairs and maintenance work may only be performed by employees who have completed relevant high-voltage training. All high-voltage technicians receive this training via the Audi e-tron distance training program. Expert training for the Audi e-tron is available to high-voltage technicians at service centres. Please remember that any employee who uses or operates a high-voltage vehicle must have received the relevant training.
Now that you have had an overview of the components, we will show you the different driving modes and energy flows.
When accelerating electrically, the current flows out of the high-voltage battery through the power and control electronics and into the electric motor to drive the front wheels. Depressing the accelerator pedal activates the boost function and the combustion engine starts. At this point, the entire 150 kilowatt system power becomes available. If the accelerator pedal is released completely, the vehicle changes to coasting mode. The electric motor uses the kinetic energy to generate current, which is then used to charge the high voltage battery. The electric motor also generates current for the high voltage battery during braking. There is no active drive when the vehicle is coasting.
The Audi A3 Sportback e-tron accelerates in boost mode at an impressive torque of 350 Nm. The model's top performance is therefore achieved at a minimal consumption level. More information can be found in Self-Study Program 627 Audi A3 Sportback e-tron.
We are always looking for ways to improve our programs. Please send any suggestions, improvements and topic requests you may have to audi.service.tv@audi.de.